Yeah.
As Matthew should have explained, there's only two conditions for the alternating series test, which are pretty self-explanatory, and the first example I'm going to do is a pretty easy one. So our b sub n would just be 1 over n. So the first condition you'd have to check would be to see what this is equal to as n approaches infinity. Which as n gets larger, this converges to 0. So the first condition is checked off. And the second condition is to see whether b sub n is always greater than b sub n plus 1, which, as you can see, it is. You don't have to take the derivative. So 1 over n is always greater than 1 over n plus 1. So by doing that, you can determine that this series is convergent. And now to the second example. Okay, so this is our series, the sum from 1 to infinity of this function, which our b sub n would just be the term without the negative 1 raised to the n. And now we check our first condition. Which, as n approaches infinity, this will approach 1. And so this is not equal to 0, which means that this series is divergent. And the final example is a little bit trickier, which is okay, that's the series, and b sub n is the square root of n over n plus 4. Our first condition that we have to check. And this is obviously 0. Our second condition, it's not quite intuitive as to whether this always decreases, and as you'll see in a second, it doesn't always decrease. So we'll make a function of f of x equal to the square root of x over x plus 4. Taking the derivative gives f prime of x is equal to, I'm not going to work through this quotient rule, but it's equal to 4 minus x over 2 times the square root of x times x plus 4 squared. So that's the derivative, and this derivative has 3 points or critical points, which are x equals -4, x equals 0 and x equals 4. When x is equal to -4, the denominator is undefined, and when x is equal to 0, the denominator is undefined, and when x is equal to 4, the numerator is undefined, and the slope is 4. So we don't care about x equals to -4 because it's out of the bounded region that we care about, which is 0 to infinity. And so from 0 to 4, the function is, so let's just try f prime of 1, which is equal to 3 over 50. So the function from 0 to 4 is increasing, but the function at f prime of 5 is equal to negative square root of 5 over 810. And so since the derivative at 5 is negative, we can tell that the function from x is greater than 4 will be decreasing. So we can conclude that the series is convergent. And that is the final example. Yeah.